Section 12.4, Simplifying Complex Rational Expressions. In this section we will work with complex rational expressions. A complex rational expression is a rational expression whose numerator or denominator, or both, is a rational expression. Here are some examples. And here we find values of two numerical complex rational expressions. I have 2 over 2, which 2 over 2 would equal 1, so I have 2 over 1, and that equals 2. Here I have 2 over 2, and that is over 2. Since 2 over 2 is equal to 1, this is 1/2. From these two examples, we see that it is important to keep track of the main fraction bar, the longest one in bold, of the two complex fractions. We will discuss two methods for simplifying complex rational expressions. So if the choice is yours whether or not you want to use method 2 or method 1. So compare method 1 in examples 1 and 2 and method 2 in examples 3 and 4 and decide which one you like better. Example 1, I'm going to simplify this by using method 1. So method 1 involves taking the numerator and dividing it directly by the denominator. So my numerator, or in this case I will call it r, over s. So I want to take r and divide it by s. My r is 12 over x. I'm going to divide this by 8 over x cubed. So this, I will have to take 12 over x and multiply it by x cubed over 8. I'll cancel whatever I can cancel. 4 goes into 12 3 times and into 8 twice. X goes into itself once and into x cubed, x squared times. So I have 3x squared over 2 as my solution. Next I want to simplify x squared minus 9 over, or x squared minus 9 over x squared plus 2x plus 1, all of that over 2x minus 6 over 4x plus 4. So I'll take the numerator and divide it by the denominator, which involves multiplying by the reciprocal. I'll factor the numerator and I'll factor the denominator of each of my fractions. Then I'll cancel whatever I can cancel, so x minus 3 cancels with x minus 3, x plus 1 cancels with x plus 1, and the 2's will cancel, and I'll be left with 2 times x plus 3 over x plus 1. Example 2, I want to simplify 1 over y squared plus 3 over 2x, all over 2 over y minus 1 over 3x. So I want to take my numerator and my denominator and eventually divide them. But first they need to be one fraction. So I need to combine my numerator so I have one fraction. So my y squared is missing 2x factor, so I need to multiply the top and the bottom by 2 over x. 2x is missing y squared, so I need to multiply the top and the bottom by y squared. And the denominator, my y, is missing a 3x factor, and my 3x is missing a y. So once I multiply this through, my numerator will have the same denominators, and my denominator will have the same denominators. I can then combine like terms so that I have one fraction in the numerator and one fraction in the denominator. Once I have this, I'll divide the numerator by the denominator, which involves multiplying by the reciprocal. And then once I multiply, I'll cancel whatever I can cancel, and I end up with 3 over 2x plus 3y squared all over 2y, or 3 times 2x plus 3y squared, that all over 2y times 6x minus y.